Hello guys, welcome back to my YouTube channel. Today also we would be discussing one of the most asked Google interview question. So we would be discussing this question today. And the question is height of binary tree after subtree removal queries. So the question states that you are given root of a binary tree with n nodes. Each node is assigned a unique value from 1 to n. You are also given an array queries of size m. You have to perform m independent queries on the tree where in the ith query you do the following. Remove the subtree rooted at the node with the value queries I from the tree. It is granted that the queries I will not be equal to the value of the root. Return an array answer of size m where answer I is the height of the tree after performing the ith query. The queries are independent, so the tree returns to its initial state after each query. The height of the tree is the number of edges in the longest simple path from the root to some node in the tree. So let's consider this example. So in this we are given this tree, and initially the height of this tree is 3, but we are given the queries as 4. So we are, if the query is 4, then we will remove the complete subtree uh, containing that 4. So this complete part will be removed and we will be left only with this part, and its height is 2, so we have to return 2. If we go to example number 2, let me also take out my pen. So here this is our given tree, and suppose so initial height is 3, so this is the path. You can go from here, and you can go from here, and you can go from here. So this is the path, and you are given initial first query is 3. So if 3 is given, then this complete will be removed. So if this completely removed, then also the height will remain 3 only. So first answer is 3 here. Then we are given 2. So in this case we are removing this 2 here. So this complete portion will get removed. So this will not exist now. So if this will not exist, then we will be left only with this. So here height will be 2. You can conclude this will be the height. So here answer is 2. So in the similar way, I think if 8 is removed, so if you see like if we are removing this 8, so this complete tree will be removed, and the new height will again be 2 because this one and this one. So here 2 is given. So I hope you have understood the question. So let's go to see its explanation. Let me open the pen again. Let me erase it completely. One minute, guys. Let me open the pen again, and I think I'll have to erase it. So yeah. So if we maximize it, so let's consider the example of this tree we are given. 5 is the root node, 8, 9, 2, 1, 3, 7, 4, 6. So initially what we will do is we will store what is, like, first of all we will calculate the maximum height of the given tree. So for this given tree we will calculate the maximum height, and we'll also find out the path through which that maximum height is gaining. So for 5, as we have calculated 2, 4, 5, 8. So this is the path, this one. This is the path through which our maximum height is being attained. So how we'll calculate this? So initially so like suppose for the leaf node we are just assigning this 4, and 6 is assigned. Then we will analyze its parent, and then we will see what is, if left height is, the number of elements present in the left is 1 and right is 1. So we can consider either of the two. So suppose we consider the left one, and we will add 2 here. So here it will become 2, 4, the maximum path. Then in case of 8, from here it will come 1, and here 2, 4. So we'll pick up 2, 4, and we'll also attach 8. So maximum path from 8 to any 2 subtree of 8 is 2, 4, 8. So this is also done. So when we will come to this, from 9 it will be 3, 9, and for 5 it will be 2, 4. We will also add 5, so it will become 2, 4, 5, 8. So in this way we will calculate the maximum path, and like we can calculate also through this. If we know this set, we can calculate what is the maximum height currently for the given tree. So maximum height will be 3, so it will be size of this set minus 1. So here our maximum height will be 3. So what will the time complexity of calculating this? It will be O of n, where n is the number of nodes, because we are going to each and every node only once. We will use DFS in this case. And so suppose we have understood like how we can calculate this, and now let's take the example of this tree. Now forget about this one, let's take the example of this. So in this, now we already know here our set will contain 2 and 4, 5, 8, and it will also contain 10. Understood? So this will be our set. So out of this set, like if any of the number is given out of this set, then the height of the tree will change. Suppose in our query we are given 9, so this will get removed, but still the height will remain same only, like it will be 4 only. So if any of the number in the queries is given out of these, then our height will change, otherwise our height will remain same. This is the main idea. So if suppose now we'll consider the case if any one of these number is given, then how we'll calculate the height of the tree. So suppose we are given 5 is given to us, or suppose 10 is given to us, then we will calculate the height of the remaining, then we will not consider 10, and we'll calculate the height of the remaining tree in our normal. And normally how we calculate the height of a tree in O of n steps. So we'll calculate the height of the remaining tree. So now let's calculate the time complexity. So total queries will be of the range n only, and so these elements should be, count of these elements will be log n. So for n minus log n only, will if we know the height of the tree, this we have already calculated, this is already done. So for the remaining nodes, time taken would be just O of 1. So from there the time complexity will come as n minus log n, and for these log n elements nodes, for each of these nodes the time complexity will be n. So here the time complexity will be log n into n. So total time complexity will come out to be log n into n. So this is still acceptable, because in the question we are given that n value is given as 10 to the power 4 only. Let me cut this one. So here n value is given as 10 to the power 5, so our n log n solution will work. So I hope you have understood the question. So let's go to the coding part. So in the coding part, what we are doing is so this is our given function, and we are given queries, and we are also given roots. So first of all we will calculate this set path, and we'll calculate the, we are passing it through a height function, the root node, and we'll calculate the path. Here path refers to this path which we are calculating. This is the set which we want to calculate. So using this height function we are calculating. How we are calculating? We are just using DFS. So if in the height function we go, so if the left and right child of this current node are null, then we will just insert it in the empty set and return empty set. Otherwise we'll check whether left is present or right is present, and if left side is greater than or equals to, then we'll insert the value in the left set. Otherwise we will insert the value in the right set and we'll return the right set. So in this way we can calculate our path. So max height will be size of this path minus 1. So as you can see here, max height is 3, here size is 4, minus 1 3. So here height will be 3. And now we'll create one answer vector which will contain answer of each of these queries, so its size will be same as the queries vector. And now we are what we are doing is we are processing each query one by one. So we are seeing like we are taking out one query and we are checking whether this query is present in our path or not. If it is not present in our path, so answer will be our max height, which is already which we have calculated. Because you can see if the input is 9 or 3 or 7, then our maximum height in this case will remain as 4. So our maximum height will not change, so we will assign the same maximum height. Otherwise if the one of the query is lies in this path, then we will pass one another function height after removal. So we will kind of remove this current query root node, and then we will calculate the height of the remaining tree. So what I'm saying is so if we are removing this 2, so if 2 is given, then we will completely remove this 2, this complete subtree, and for this remaining subtree we will calculate the height of this remaining tree. So the same we are doing for every root node. We are calculating what is the left height and what is the right height, and here we are uh, also keeping a track of bool value executed. So initially it is set to false, so we'll check if root left is set and it is not equals to query, because if it equals to query then we don't want to go there. So if it is not equals to query, then we'll assign the left value, and we'll set the executed as true. I will tell you why we are considering this executed boolean here. Same is the case for right side. We'll check whether right side exists, and right side value is not equals to query, so we'll again use the recursion, and here also we'll set executed as true. So if executed is false, means neither it has gone into this if function and neither it has gone to this if function. So in that case like there is no left child and right child, so in that case we will return the height as 0. Otherwise we will just see what is, we will take the max of left and right and we will add +1. So this is just the normal function, the way in which we calculate the height of a tree. So nothing fancy here. We are just considering one extra edge case, like we will not go into a query subtree. So in this way we'll return the answer, and yeah, I think this code should work. Let me also run this code and check whether it is working fine. So I'm running it. Let me increase the size of it. So yeah, test cases have passed, and now I will submit it. So yeah, it has got accepted. So yeah, this solution is working. So I'll attach this solution in the comment section, and I will also add the problem link in description, in the description of this video. I hope you have understood this question, and do like this video and subscribe to my channel, and stay tuned for more such important data structure and algorithm questions. So yeah, thanks and have a nice day.